Okay, one of the things we're asked to do in geometry is to prove the slope formula. And you know the slope formula, or at least you know how to find the slope of a line, usually, or at least in 8th grade math, and in algebra we had you drawing pictures, drawing right triangles, you count the vertical change, you count the horizontal change, and then you write a fraction. Rise over run is your slope. So here we have a slope of 2/3. And we're just going to dig a little deeper into that idea. So take this point right here. That is located at 6, 4. And this point right here, that is located at 3, 2. And we're going to do a little bit of subtraction to get that slope. The rate of change is the change in y divided by the change in x. So the change in y is 4 minus 2, and the change in x is 6 minus 3. And then if we solve that, we are right back to the slope that we got when we just counted it off the graph. And that works with any 2 points as long as you reduce the fraction. For example, I could take this point down here. That looks like it's -6, -4. And again, change in y divided by change in x. So the change in y would be 2 minus -4 divided by the change in x, which would be 3 minus -6. And 2 minus -4 is +6. 3 minus -6 is +9. And of course, 6/9 reduces to 2/3. So now we're going to take that same idea and generalize it with some algebra to develop the slope formula. So let's turn the grids off and say we have this point right here, and we don't know what to call that point, so let's just call it x1 and y1. And then say we had a point down here, and it's just some generic point, so let's call it x2 and y2. And now we were going to do the same thing. We want the change in y divided by the change in x. So that is y1 minus y2 over x1 minus x2. And there it is. That's the slope formula. Just plug in the ordered pair. This looks a little different, but it's exactly the same as y2 minus y1 over x2 minus x1. As long as you keep your x2s and your y2 and your x1 and your y1, as long as you keep those lined up, then you're going to get the same thing when you do that subtraction. And I think, generally speaking, when you see it written down, this is the form that we usually see. So there you go. That is the derivation of the slope formula.